Welcome everyone. This is your first lesson on beginning to be a chemist, and this lesson relates to the states of matter. The experience and outcome that this comes from is understanding models of matter and applying this knowledge to understanding changes of state. That'll make more sense as we go on. So you may have some ideas in your head, or maybe you think you're not sure about what is chemistry. What I'd like you to do now is you can either pause the video or just keep a list of ideas in your head about what you think chemistry might be. I would say that a lot of you watching this probably think chemistry is scientists in white coats and goggles doing experiments, and probably something to do with chemicals. And that's true, but chemistry is really the science about how different materials interact with one another. So that could be how acids interact with things, that could be how explosions happen. But it's also things like how do we make materials for clothes that will make them last longer, make them waterproof. It could be how do we make makeup that can be cleaned off easily or will last a long time. Or it could be making paints. How do we make them a particular color? Making medicines, making fuels. If anything that you can actually pick up and hold in your hand is a chemical, and chemistry is about how we can use that for the benefit of everyone. So chemistry is a really wide topic. And what we need to know is that what we call chemicals, we can also describe as being matter. Anything that you can interact with is matter. And all matter is made of tiny particles called atoms. So every single thing, every part of you, every part of the chair you're sitting on or the stool that you're sitting on, the walls around you, the roof over your head, the air, that's all made up of atoms. And an atom is the smallest possible unit that matter can be made up of. So looking in this diagram, if you take a magnifying glass, you can start to see how rough the lead is, but you have to zoom in really close before you can start to see atoms. And atoms look a little bit like this. They have a nucleus at the center, and around that nucleus are lots of things called electrons that are moving really fast. And that's the basis of all matter, all chemicals. Now, there are three main states that matter can exist in, and you will probably have heard of all of these. I'm sure all of you have heard of these. Solid, liquid, and gas. But what makes a solid, what makes a liquid, and what makes a gas? Well, it's all to do with the way that these particles or atoms are organized. And if you have time, what you can do is think of how many different solids, liquids, and gases you can see in the room that you're in or in the lab, if you're in the lab, and think about why you made your choice. So you can pause the video now to make that list and think about why you made your choice as to why that's a gas, why that's a liquid, and why that's a solid. Okay, now let's see whether or not your reasoning makes sense. So as I said, the states of matter, they all are made up of the same atoms, but it's just the way that the particles are organized. So we can see in a solid, all these particles that we've drawn as circles, they're all very regular and they're all very close together. Then in a liquid, they're still very close together, but they're now randomly organized. And then finally, we've got a gas, and we can see that the particles inside a gas, the circles there, are not touching, and they're filling up all the available space in that container. We'll look at each one in a bit more detail. So, for particles in a solid, the particles are very close, and they are very regular. That means they're organized in rows and columns. Now, the particles themselves, they cannot move about. They're stuck in one position, and all they can do is vibrate left and right, left and right, left and right. But they cannot move about. They're fixed in one position. Now, solids, because their particles are like that, it gives them some properties. And a property just is a way of describing how something is or how it acts. So some solids are hard, some solids are soft. But a solid always takes up the same space. And another way to describe that is that a solid keeps its volume. And if you leave a solid alone, it won't change shape. It'll keep its shape. So the chair you're sitting on, it's a good thing that it's a solid, because if it wasn't a solid, it wouldn't keep its shape, and as soon as you sat on it, it would move. Now liquids are the next state of matter, and you can see from this picture that the particles are close together, but they're not regular. They look a bit jumbled up. And because they're jumbled up and they're a little bit further apart than in a solid, the particles can move. So particles in a liquid are always moving around one another, constantly moving. Now, what this allows a particle to do is that liquids flow. So if you try and pour a liquid from one container to another, because the particles can move, it can flow easily. However, a liquid keeps its volume the same as a solid, and that's because the particles are close together. So even though the particles might be able to move, they still have to stay close together, and that means that a liquid keeps its volume. But liquids change shape, and they change shape to whatever container they are in. So the way a solid keeps its shape, liquids don't. They change shape. And finally, we have particles in a gas. Now, particles in a gas are really far apart. The circles don't touch each other at all, and it's really not regular. Now again, because they have lots of space, they can move very, very easily. Now what this does is it allows gas to flow. So you can move gas from one container to another. If you open the window, you feel a breeze. That's because gas is moving from one side of the window to the other. It's flowing. Gases are able to change volume. So if you put gas inside a plastic bottle, you can squeeze that plastic bottle and get it to change volume. Whereas a plastic bottle that's filled with liquid, you can't squeeze it very well. And that's because the particles are taking up all the space. You can't squeeze it anymore. But in a gas, because there's a lot of space between the particles, when you squeeze a bottle filled just with gas, you can squeeze it and it changes shape and changes volume. So a way that you can do this is if you fill, and it can be a bottle rather than a syringe, is to fill a water bottle with water, tightly seal it and see whether or not you can squeeze it. Then empty the bottle or drink the bottle of water, depending on what it is, and try and squeeze it again. If you do that, I'd like you to try and explain why there's a difference. So that's an experiment that you can do in your own time, or next time you have a bottle of water, when you buy it, see if you can squeeze it, and then after you've drank it, can you squeeze the bottle? And try and explain why. So if you have tried that experiment, here's an explanation of why. So in the bottle or in the syringe, the liquid has particles really close together, but the gas has only a few particles inside and they're far apart. If you try and squeeze the liquid, the particles have nowhere else to go, so you can't squeeze it. However, a gas, if you put pressure on them and squeeze it, they can take up a lot less volume and be moved together here. So in the liquid, particles are close, cannot be squashed. In the gas, the particles are far apart, so they can be squished. Here is a question for you to think about, and it's to do with sponges. Now, sponges are solid, however, they can be squished, and a sponge can soak up water as well. I would like you to think of reasons why a sponge can do that. What is special about a sponge that would allow it to be squished and would allow it to soak up water? So we're not going to go through the answers during this presentation, but that's something for you to think about and you might get asked whenever you're in class. So here's a summary of everything that we've covered. So we've got pictures of the particles inside a solid, a liquid, and a gas. You can see that the particles in a solid are very close, the particles in a liquid are close, and the particles in a gas are far apart. If you're asked, does that type of material, that type of matter, flow? Well, a solid cannot flow because the particles do not move. Liquids and gases can flow because the particles can move. Next question you could be asked is, can that state of matter change shape? For a solid, the answer is no, and that is again because the particles cannot move. But a liquid and a gas, because the particles are able to move, they can change shape. So a liquid and a gas, yes, they can change shape. And the final question is, can it change volume? Now this is related, this question is related to whether or not the particles are close together or far apart. The particles in solids and liquids are close together, and that means that they cannot change volume. But the particles in a gas are far apart, so yes, it can change volume. So that has been a summary of solids, liquids, and gases. The next stage is going to be a series of questions where a question will be asked. If you pause the video, you're able to answer it, and then the next slide will have the answer on it. So you can keep pausing and playing along. So this is the first question. Everything is made up of tiny particles called what? So either pause, write down your answer, or just keep it in your head. And the answer is atoms. Next question. Atoms are the what unit of substances? So that blank space, we're looking for an adjective, a description of the type of unit atoms are for substances. The answer is the smallest, or you could have gone for simplest. So in this one, I'd like you to draw a diagram to show what the particles look like in a solid. So they look like this. They are regular, they are close together, and they're in rows and columns. Next question is, this time, draw the particles in a liquid. Okay, so the particles in a liquid look like this. They are close together, but they are not regular. They're drawn a bit random. Next question. Imagine you know what this one is. Draw the particles in a gas. For this one, what we're looking for is the particles far apart and in a random order. So in this one, we've got a picture here, and there are 6 statements. 2 of the statements correspond to the picture of a solid, 2 of the statements correspond to the picture of the liquid, and 2 of them correspond to the picture of the gas. So read the 6 statements and then decide which ones describe a solid, which ones describe a liquid, and which one describes a gas. So, first one, statement A, this diagram shows how particles are arranged in a solid. Statement B, this diagram shows how particles are arranged in a gas. Statement C, this diagram shows how the particles are arranged in a liquid. Statement D, the particles have spaces between them and are spread out. They move very fast. The next one, particles have some spaces between them, but still touch. They can move over one another easily. And statement F, the particles have no space between them. They can only vibrate slightly. So what we have, the top one is a solid, and that's statement A and F. So it's particles arranged in a solid, no space between them, they can only vibrate. The second one, that's a picture of a liquid. So that's statement C, that says it's a liquid, and E, which talks about there being some space between them, but the particles touch, but they can move easily. And the last one is B and D. That's the particles arranged in a gas, and the particles are spread out, spaces between them, and move very fast. So for this one, all you're being asked to do is come up with 3 examples. 1 example of a solid, 1 example of a liquid, and 1 example of a gas. So you can pause the video to write those down and then start it back again if you want to see the examples I gave. So the examples I gave, the solid was ice, the liquid was water, and the gas was steam. But you could have anything. This question had so many different options. Now this one, what you need to do is decide which of the 2 words in bold and underlined is correct. So particles in a solid are held together more or less tightly than a liquid. Which word is correct? So it is, particles in a solid are held together more tightly than a liquid. Next one, particles in a gas are held together more or less tightly than a liquid. Well, the particles in a gas are held together less tightly than in a liquid. Now this is a question you might need to pause and think about and maybe write down a couple of sentences. But why can a beach ball be easily squeezed? Now a beach ball is one of those inflatable balls that you have to blow up, in case you weren't sure. So the reason is because a beach ball is blown up, it's filled with gas, and gas particles have lots of space between them, which makes it easy for you to squash them closer together. Why can't iron? So why can't the metal iron be squashed easily? Well, in this case, it's because iron is a metal and it's a solid, and the particles have very little space between them. They're already touching, so you cannot get them even closer together than they already are. So you cannot squish it. Finally, we've got a few questions where again, choose the right word. If you leave a solid, it will lose or it will keep its shape. The answer is keep its shape. A solid always takes up the same space. In other words, it what its volume. What word goes in that missing space? The answer is it keeps its volume. Now this one, we've got two words. A liquid keeps its what? And liquids change what? So what we have is a liquid keeps its volume, but liquids change shape. And this is our final one. Decide, does a gas keep or change its volume and its shape? The answer is a gas changes its volume and its shape. So thank you for spending the time to go through this lesson and then to have a go at those questions at the end. Next lesson, what we'll be looking at is how things that are solid can change into liquids and how things that are liquids can change into gases, and the reverse as well. So thank you for paying attention and for sticking it out, and I'll see you next time.